Okay, so in this video, we are going to learn about new type of function, the logarithmic functions. So for the values x greater than 0 and for b greater than 0 as well as b cannot be equals to 0. So the logarithm functions with base b is written as y equals log b of x. So this expression is asking to what power we must raise b to get x. So we say the log bx equals y means b to the power y equals x. So these two expressions are equivalent to each other. So in other words, logarithms ask you to tell the exponent. For example, if you have, we already know 2 to the power 3 is equals to 8. So if you're asked to write this in logarithmic form, what you have to do is you write your log first and then you write your base. So if you consider this expression, you know the 2 is the base and 3 is the exponent. So here, first of all, you write your base as a superscript here and then you write your output. So this expression asks you to tell the exponent that we need for 2 to get 8. So we know 2 to the power 3 is equals to 8, which means the logarithm of 8 of base 2 is equals to 3. So here you can see the output is the exponent. Okay, so what is the connection to the exponents? So the logarithmic function is the inverse of the exponential function y equals b to the power x. That means exponential functions take an exponent and gives you a number. And on the other hand, logarithmic function takes a number and tells you the exponent you need. So let's try some example, then you will understand this concept clearly. Okay, let's practice rewriting exponential equations in logarithmic form. So if you remember, this is the relationship between exponential functions and logarithmic functions. If you have exponential function as b to the power y is equals to x, you can write that the same expression as log with base b of output x is equals to y. Okay, so let's try some examples. So in the first example, 3 is the base, 2 is the exponent, and 9 is the output. So you can write this as logarithm with base 3, the output is 9, and the answer will be equals to 2. And for the next example, you write again log, and here the base is equals to 4. Okay, the 4 goes as a subscript and the output is 1/4 and the exponent is -1. And here third example, again 5 is the base, 1 is the exponent, and this is my output. So log base output and the exponent. Last example, log, you write your base, here base is equals to 3, y is the exponent, x is the output. So you write your output and you write your exponent. Next, let's move to the next example. Okay, so now let's practice going in other way, converting logarithmic equations into exponential forms. So this is the connection between logarithmic functions and exponential functions. So the log of x with base b equals y means b to the power y equals x. So let's use this connection to write these logarithmic expressions in exponential form. So here the base is equals to 2 and this will be the output and this is the exponent. So we can write this as 2 to the power 4 is equals to 16, and this is a true statement because if you multiply 2 by itself 4 times, you'll get 16. So next example. So in this example, the base is 10 and this will be my output and this is my exponent. So 10 to the power negative 4 will give you 0.0001. Next example, here exponent is 0, output is 1 and the base is 6. So 6 to the power 0 is equals to 1. So because this is your output, this is your base and this is your exponent. Moving on, the next example. So now let's practice working with logarithmic functions. So here we are going to rewrite, evaluate and use exponential forms. So let's read first part. So you're asked to write this expression in exponential form. So here this 2 represents the base and this is my output. Y represents the exponent. So you can write this as 2 to the power y equals x, because 2 is the base, y is the exponent. So 2 to the power y gives you x. Okay. Next part, use exponential form of part A to find y when x is equals to 8. Okay. So let me write the same expression with x equals 8. So next question is, what is my y? So here we already know that 2 to the power 3 gives you 8. So if you multiply 2 by 3 times, you'll get 8. So here that means y is equals to 3. So this is the answer for second part. Next, you're asked to get logarithm of 8 with base 2. Okay. By looking at part B, you can answer part C. Okay, so here we know 2 to the power 3 gives you 8, which means the answer for this is 3, because if you raise 2 to the power 3, you'll get 8. Next, you're asked to get this logarithmic expression. So here you know that 2 to the power negative 2 is equals to 1 over 2 to the power 4 to the power 2, and this is 1 over 16. So that means if you raise 4 to the power negative 2, you'll get 1 over 16. So here you're asked to write logarithm of 4. That means you are asked to get the exponent with base 4 to get 1 over 16. So looking at this expression, you know the answer is negative 2. So here the answer is 3. Next, let's move to the final question. So here you have to evaluate logarithm of 0.001 with base 10. So here we know that 10 to the power negative 3 is equals to 0.001. So that means the exponent that we need is negative 3. So here I have logarithmic functions. So when b is greater than 1, the logarithmic function will be of this shape, and you can try to explore this using your calculator. And if the b is in between 0 and 1, then your logarithmic function will be of this shape. So here you can see in this graph the x-intercept is 1. In both graph, x-intercept is 1 and you will not find any y-intercept. So the domain is all positive x values and the range is all real numbers. So here you can find a vertical asymptote, which is the y line.